Good afternoon, respected lecturer. My name is Ma Ziyan. My matric number is 8220730. This presentation is for the STQM 1043 Calculus course. My topic is application of derivatives in economics, focus on notional analysis. Today I will spend 15 minutes explaining how calculate derivatives some real business profit problems. Now let's move to our table of contents. Now look at our table of contents. We have 5 parts in total. First part, introduction. We will talk about marginal analysis and this uses business choices. Second part, comparison. We will learn derivatives, the method to calculate fast changes. Third part, key economic application. We explain marginal cost, marginal revenue, and marginal profit and how they connect. Fourth part, case study about maximum profits. We used a phone case factory example to find the best production number. Last part, conclusion. We talk about how marginal analysis help companies run business well. Let's access our first part. Now let us look at this page. What's the marginal analysis? It has 4 easy parts. First, core definition. Marginal analysis help people make choices. It compares actual money we get and actual money we spend. It only looks at small new changes. Now, all total numbers. Second, the critical question we think about this is if we and port, how will our port change? We only care about the next one, products or worker, not all of them. Third, business values. Shop and withdraw uses how many goods are to make, how much to sell, and how many workers to hire. It helps them use money well. First, calculus connection. We use derivatives read as divided by dx to calculate these small changes. Derivatives is the basic method for marginal analysis. This slide talks about derivatives or core method. There are 3 simple parts. First, mathematical definition. We have function y equal f of x. Its derivatives read as f prime x dx show how fast y changes when x has a tiny shift. Second, geometric interpretation. Look at the core graph of left. The derivative at point P0 is the slope of the tangent line. It tells us steep course is there. Third, economic meaning. Marginal cost. If C of x the total cost, C per x mean marginal cost. It is extra money to make one more product. Very important to get the largest profit. The picture on the left corner showed its tangent line idea for derivatives. This slide is about marginal cost. Short of MC, it has 3 small parts. First, core definition. Marginal cost means the actual money to make one more product. Second, the master formula. MC is equal C prime x. Also read as dc by dx. It is the first derivative total fraction. Third, simple example. Total cost C as equal 500 times more % by x plus 0.01 plus by x well. F combination MC of x equal 10 plus 0.02 most by x. When x is 100, MC equal 12. making the 101st product cost about $12. The factory picture told the factories use MC to find the best output number. This slide talks about marginal revenue, short for MRR. First, definition. MR is the actual money we get when we sell one more product. Second, formula. MR of X equal R per X. Read as DR divided by DX. It's the divergence of total revenue. Third, core losses. If we sell more goods, MR will become smaller. It helps us make more profit. The calculation is shown on this picture. The result means selling the 104 products at the real $14 to our income. If marginal cost is less than $40, making these products can make money. This slide is about marginal profit, short for MP. First, definition. MP is the actual money we earn for making and selling one more product. Second, profit formula. Profit P of X equal to total revenues R of X minus total cost C of X. Third, MP formula. MP of X equal marginal revenue MR of X marginal cost MC of X. Wiki rule for most profit is shown on the picture. We get the lowest profit with MP equal 0, which means MR equal MC. These pages are case study background. The page shows a factory that makes phone cases. First, cost and prices emissions is shown on the slide. We have total cost function and selling price function. Second, our goal is to find the best production number to get the biggest profits. We use marginal revenue and marginal cost to find this number. This slide is step 1 of case study. We need to work out MR and MC first. There are 3 parts here. First, total revenue, short for R. It is all money we get for sales. The formula is shown in the picture. Second, marginal revenue, short for MR. It is money we get for selling one more product. We get MR by taking the first derivative of total revenue. Third, marginal cost, short for MC. It is actual money to make one more product. We get MC by taking the first derivative of total cost. All calculation steps are shown on the slide. The keyboard at the bottom tells the beginning profit appears when MR equals MC. These two functions help us find the best product number. Now let us move on the second calculation step in our business case. We use the rule MR equal MC to solve for production number X. All math steps for this question are shown on the left side of the slide. After finish the calculation, we get 2,500. This number is the best production amount for our phone factory. The text at the bottom explains this meaning. If we make more products, our cost will be bigger than our income. If we make fewer, we cannot get all possible profit. Now we move the 3 of case study. We prove this number gives us the largest profit. There are 2 checking methods here. First one is the first derivative test. We take 2 numbers around 2,500. When x equal 2,000, the marginal profit is positive. Profit go up. When x equals 3,000, marginal profit turn negative. Profit dropped down. This proves a highest point. The second way is the second derivative test. The calculation formula is shown in the pictorial. In the picture, the final result is minus 0.012. A negative number is means this point is the global maximum profit. At the bottom, we draw a final conclusion. 2 math times both show 2,500 product is a bad production for maximal profit. Next, let's look at the first calculation step of this business case. We calculate the large profit we can get. This slide has two calculation parts. The first part is the profit formula. Profit equals total revenue minus total cost. All simplified steps are shown on the live box. The second part put our best number 2,500 into the profit formula. The whole calculation process is shown on the right. After calculation, we get the final profit $27,500 US. The tax at the border this result is we make the sale 2,500 phone cases. We can earn the highest next money after paying on production cost. Let us use the Korean graph to show the link between cost, income, and profit. On the left, there is a curved graph with two lines. Three short explanations. On the right tolerance, each means its red line is total cost. Its start curve for fixed costs and rises factor as we produce more goods. The green line means total revenue. It goes up quickly at first, then becomes flat and join when the market is falling. Profit is the vertical space between these two lines. It forms the curve opening down and reaches the curve at best output. The text at the bottom tells us the core rules. The vertical gap between revenue line and the cost line is the largest at 2,500 products. This result fully matches all our math work before. We have reached the final slide of our presentation, which covers conclusion and real-world use of these calculation methods. This page is split into two main parts. The left part is our conclusion. First, derivative calculus is very useful to business plans. Second, the rule MR equal MC is the key way to get maximum profit for all kinds of markets. Third, this method uses the real data instead of guessing, so companies can avoid making too many or too few. The right side talks about real-world influence. Big companies use it to set production number and prices well. It is also widely used in supply chain finance and market study. For students like us, this knowledge builds solid basic skills for future finance and business jobs. Thank you for your listening.